Okay, so we know some things about a polynomial function now. We know that if they give us the function, say f of x equals x minus 4, and let's make that cubed, and x minus or plus 5 squared. Let's say you have something like this. Then we can figure out the x-intercepts, right? So the x-intercepts in this case, you'd have one at 4 and you'd have one at -5. And we can figure out the multiplicity. The multiplicity of 4 is 3, so it means it's going to, cross on through like that, or it could be going the other way. And then the multiplicity of the other one of -5 is 2, and so we know that's going to bounce, right? Touch or bounce. And it might be coming up like this, or it might be coming down like that, one of those two ways. Okay, now we're going to go the other way, where they don't give us the function, but we're trying to find the function based on information that they either give us or we can read from the graph. Okay, so let me scroll up. So they call this, they'll use these directions. Find the polynomial of least degree, okay? So let's say they tell us that the x-intercepts are 2 and 3. Well, let's make it a -2. -2 and 3. And let's say they tell us the multiplicity of -2 is 4, and the multiplicity of 3 is 5. Well, then we know some things about this polynomial. We know that f of x has to have at least a factor of x plus 2, and that has to be to the 4th power. And we know that there's a factor of x minus 3, and it has to be to the 5th power. Now, they might not tell us the multiplicity. We might have to read that off the graph. And then we won't know exactly what power it is. We would only know the least degree, okay? But I'll get to that when we do an example. The other thing we have to consider when we're given this information and we're trying to find the polynomial of least degree, there could be a factor in here that we don't know, some constant, okay, or a stretch factor. So when we talk about the stretch factor, we're talking about some constant a, where a is a real number. It's an element of the real numbers, okay? We can figure out what a is. As long as we know a point on the graph, we can figure that out, okay? It can't be an x-intercept. It has to be another point on the graph. Okay, let me give you the notation that you're going to see in the book. So they're going to say f of x is equal to, and they're going to tell us, let me make a little line here, that the x-intercepts, the book's notation, they say, well, the x-intercepts are x sub 1, x sub 2, x sub 3, and so on. These are commas. Okay. So we don't know how many x-intercepts they're going to give us. Remember, we can have a lot of x-intercepts. But, they're going to give those to us, or we're going to be able to find them. Then in your polynomial that you're creating of least degree, then a is the stretch factor, and then each factor is going to be x minus x sub 1, x minus x sub 2, x minus x sub 3, and so on, as many x-intercepts as we have. But also the powers, or the exponents, I'll just put the exponents. I think they use p for power. P sub 1, P sub 2, P sub 3. Each one of those factors has a multiplicity based on the power of that factor. And we're not going to know necessarily what the exact power is, but we can do a least degree. If we can see the picture and we see that it crosses either this way or this way, we know that the degree is going to be 1, or the exponent's going to be 1. If it's doing something like this, then the least, or going the other way, then the least degree would be 3. Okay? Let me scroll this up so I can write that for you. So if it's going straight through one of those two ways, then p is equal to 1. And then if it's like curving and it's crossing through, then p is going to be equal to 3. That is least degree. We recognize it could be 5 or 7 or something, but least degree would be 3. And then if it's going like this or like this, and it's bouncing off the x-axis, well, that's a horrible picture. If it's bouncing off the x-axis, so pretend like this is the x-axis, and if it's going like this, where it's coming down and touching, or coming up and touching, then we're going to use p as 2. Okay? It could be a higher degree, like 4 or 6, but we're going for least degree here. Okay, so I think that gives us enough information to go ahead and do an example.